Welcome Year 8 to another video, this one on the gradient of lines. Okay, before Christmas we learned about the equation of a line, although very briefly. Okay, but this is all in the process of learning about the equation of lines. Okay, so specifically today we're going to learn about the gradient of lines. So, quick recap. The equation of a line is y equals mx plus c. The m equals the gradient, and the c equals the y-intercept. Okay, so we're focusing today specifically on the m value. Okay, so a quick starter. Can you name the gradient of these lines? Remember, the m is the gradient. Okay, so can you name the gradient of these lines? Pause here and have a go. Okay, so well done if you got these right. I'll put them up now for you, and I've just circled the gradient in green. Okay, so A is 3, B is 2, C is 7, D is 10, F is 6, G is minus 4, H is minus 3, and E is a little bit different. Okay, but E is 1. So well done if you got 1 for E. So let's have a look and visualize this a little bit more. So we know that every straight line or slope has a gradient. Okay, here's a line, y equals 2x. The gradient here is 2. Another line, y equals x. The gradient here is 1. And we know that because y equals x is the same as y equals 1x. Okay, so that helps us explain E beforehand, question E on the last slide. And another line, y equals 4x. Here the gradient is 4. Okay, so here's a question for you. Which one of the lines is the steepest? Okay, there's the lines. Which one of the lines is the steepest? Pause here and have a go. Well done if you got it right. The answer, y equals 4x. Okay, now, can you tell me what makes it steeper than the other lines? So have a think. And pause here, have a think. Well done if you got it right. It's the number in front of the x. Okay, so if the number in front of the x is larger, the gradient is steeper. Written there in the yellow box. So pause here and copy that down. Okay, some more questions. Here it says write down the gradient for each of the lines below. So pause here and have a go at that. Then, once you're done, you can answer the 3 questions below. So I'll read through them quickly. The bigger the gradient, the steeper the line. We need to remember that. Keep that in mind. So question 1. Which of the lines above is the steepest? Question 2. Which line is the least steep? And question 3. Do you know what happens if a gradient is negative? Okay, so that's what I want you to have a think about. And there's an example of a negative gradient there, y equals minus 3x. So pause here and have a think about that one. Okay, you're right. This is what we know. We know that the red line has a larger gradient than the blue line. Big gradient gives a steep line, there we are, and a small gradient gives a shallow line. So the red line is steeper than the blue line. So let's think back to that previous question. happens if the gradient is negative? Well, a negative gradient switches the direction of the line. Okay, so here's an example of a negative gradient. The yellow line there. Okay, as you can see, it's going the other way. It's going in the other direction. Okay, this yellow line is actually y equals minus x. Okay, so as you can see, if you've drawn y equals x before, it's just the opposite way round to y equals x. Okay, y equals minus x. Just to help you visualize that a little bit more, I've just done this small animation and I'll talk you through it. So here we have a line, but all of these lines have a positive gradient. Okay, I'll show you again. All of these lines have a positive gradient. The next line, a purple line here, shows all the lines with a negative gradient. All the lines that you could possibly have with a negative gradient. Okay, it says all the lines that have a negative gradient. Take into account, these lines do go through the origin. You could have both positive and negative lines that don't go through the origin. Okay, but we'll look at that further down the line. So another question you might be asked is to find the gradient. So if we have a line on an axis, how do we figure out what the gradient of that line is? So let's have a look. Count across one square, then go up to the line and count the squares going up. Okay, so this is the first technique we're going to show you. First, we count the square across, then we count how many squares upward we go until we meet the line. Okay, so for this example, we go up one square. Okay, we can check that again from a different point. We go across one, and we count the squares upwards till we hit the line, and we have one again. One more time, we go across one, we count the squares upwards, and we get 1. So the gradient is 1. Let's have a look at a different example, but applying the same technique. So we go across 1, and we count the squares up, and we get 3. So 1 square across and 3 squares up gives us a gradient of 3. Let's have another look. 1 square across, 3 squares up. It's always good to check your answers. So, have a look at these 6 questions on finding the gradient. Pause here and have a go. So if you're getting stuck, I've just put some arrows in to give you a hint as to how to solve these questions. And there's the answers to check if you got them right. For question F, we have a negative gradient. Having found out it was a negative gradient, can anyone tell me why it was a negative gradient? So, how do we find the gradient if we didn't have squares to count? Okay, this is getting slightly harder now, but hopefully you're able to keep up. You're doing really well. So we've got a line here, and we've been given coordinates, okay, which is handy because you can use coordinates to find the gradient. The gradient equals the change in y over the change in x. The over sign essentially means divide by. So what this means is the gradient equals the change in y divided by the change in x. So what we have to work out is the change in y and the change in x. So the change in x will give us 7 minus 4, so that's 3. The change in y is 15 minus 6, which gives us 9. We complete the equation. 15 minus 6 is 9, 7 minus 4 is 3, we work that out, so we need to make sure that it's the change in y, which is 9, over the change in x, which is 3, So it's 9 over 3, and that equals 3. Okay? Now, if you have a look here, the colours are here to help, because we must remember, if we start with green and take away red, you must keep with green, take away red. Okay? So if you do 15, take away 6, to work out the change in y, you must do 7, take away 4, to work out the change in x. Okay? Let's have a look at another example. Here we have the coordinates 5, 13 and 2, 7. So we can do 5 minus 2 to give us 3. And we can do 13 minus 7 to give us 6. We need to make sure that the change in y is over the change in x. So 6 over 3, which equals 2. So a quick question. Does it matter which coordinate I use first? Let's have a look. If I do 5 minus 2, it gives me 3. And 13 minus 7 gives me 6. Okay? But what if I did it the other way round? I could do 7 minus 13, gives me minus 6. And 2 minus 5 gives me minus 3. Well, minus 6 over minus 3 also gives us 2. So no, it doesn't matter which coordinate I use first, as long as I do it the same way. So I can do 7 minus 13 to work out the y coordinate, but I would have to do 2 minus 5 to work out the x coordinate. So here's 3 questions we'll work through together. Find the gradient between these 2 coordinates. So this time we don't even have a line, we just have the coordinates, but we use the same method. So we know that the change in y is 12 minus 6. We know that the change in x is 9 minus 3. 12 minus 6 is 6. 9 minus 3 is 6. And 6 over 6 equals 1. So our gradient is 1. For b, we do the same. We could do 12 minus 2 is 10. 6 minus 1 is 5. And therefore 10 over 5 equals 2. And therefore the gradient is 2. Now c is a little bit different, because within the coordinates we have a negative number, but we can still use the same technique. So 12 minus 8 gives us our change in y, and 1 minus minus 3 gives us our change in x. Now, pause here and have a think. What is 1 minus minus 3? Well done if you got it. The negatives cancel out, which actually gives us 1 plus 3. So 12 minus 8 is 4, and 1 plus 3 is 4. So the final gradient is 1. Okay, because 4 over 4 is 4 divided by 4, which is 1. So a key note that you might want to take down is look out for coordinates with negatives. Thank you, Year 8, and well done for listening. There is now a worksheet to complete on Show My Homework, which once you've done, if you could upload it, that would be really helpful.